In December 2004, inside a New York boardroom, the company that put the personal computer on the American desk announced it was done. IBM was selling its entire PC division to a Chinese manufacturer named Lenovo. The price was $1.75 billion. The creator of the American Office Standard was handing over its factories, its engineering, and the beloved ThinkPad brand. Despite global recognition, IBM's PC business could no longer pull a profit in a market swallowed by cheap hardware and Microsoft software. Corporate IT departments watched their most trusted vendor quietly step away. The American desk lost the three letters that had defined modern work. The paradox was brutal. The IBM PC had not failed. It had won the world so completely that its own creator was no longer necessary. But the real story of the IBM PC is not only the story of a corporate sale. It is the story of how America bought the future in a beige box, and how the architect of the Standard lost control of the very machine it gave to the world. Every week, we tell the stories of American devices, platforms, software, and systems that once taught the country what the future felt like and what happened when the market moved on. Subscribe if that history matters to you. The story begins not with nostalgia, but with a specific place, in Boca Raton, Florida, in 1980. In 1980, the American corporate landscape ran on paper, typewriters, and massive mainframes. In the headquarters of Fortune 500 companies, computing power was a centralized resource, locked away in air-conditioned, glass-walled rooms. Down in the actual office cubicles, data moved at the speed of inter-office mail. If a financial analyst wanted to run a complex forecasting model, they filled out a request, handed it to the IT department, and waited days for a printout. The concept of a personal computer, a computer designed for one person to use directly at a desk, existed, but it had not yet crossed the threshold of corporate trust. In dorm rooms, garages, and hobbyist clubs across America, machines like the Apple II, the Commodore PET, and the Tandy TRS-80 were sparking a digital revolution. But to the procurement officers and IT managers of major corporations, these were novelties. They were viewed as plastic toys for enthusiasts, lacking the service contracts, the standardized keyboards, and the sheer corporate gravity required for serious accounting or database management. The American office did not just need a microcomputer. It needed a psychological guarantee. It needed a brand that promised stability. It needed international business machines. Known as Big Blue, IBM was a monolithic empire based in Armonk, New York. It was famous for designing every single piece of its hardware and software in-house, from the silicon chips to the operating codes to the physical metal cabinets. A typical IBM product took years to develop, weighed down by endless committees, rigorous testing, and proprietary standards. But in the summer of 1980, IBM executives realized the microcomputer market was moving too fast. If they did not act immediately, a generation of young office workers might grow up trusting Apple or Commodore instead of IBM. To solve this, IBM isolated a small, secretive engineering team in Boca Raton, Florida. Codenamed Project Chess and led by executive William C. Lowe and later Don Estridge, this group was given an unprecedented mandate: bypass the sluggish corporate bureaucracy and build an IBM personal computer in exactly 1 year. To meet that impossible deadline, the Boca Raton team had to break the most sacred rule of the company. They could not build the machine from scratch. Instead, they had to assemble it using off-the-shelf parts from outside vendors. This single pragmatic decision would permanently alter the history of global technology. Instead of spending years designing a proprietary processor, the main chip that performs calculations and executes instructions, the team bought the 8088 microprocessor from Intel. Instead of developing their own internal software architecture, they sourced standard components from companies like Tandon, for disk drives, and Zenith for power supplies. Most importantly, they did not have time to write an operating system, the core software that manages the computer and lets other programs run. Instead, IBM licensed an operating system from a tiny 32-person company in Bellevue, Washington, called Microsoft. At the time, IBM believed the real money and the real power remained firmly in the hardware and the corporate badge. Software was viewed merely as a necessary tool to help sell the physical machine. Because they viewed the operating system as a low-value commodity, IBM allowed Microsoft to retain the rights to license that same software to other companies. It was a contract clause that seemed irrelevant in the rush of 1980, but it was the crack that would eventually shatter IBM's empire. By the summer of 1981, the machine was ready. It was not a technological marvel. It did not have the most advanced graphics on the market, nor was it the fastest machine available. But it was built like a tank. Housed in a heavy beige steel and plastic case, it looked like a serious piece of office equipment. It featured a high-quality, heavy mechanical keyboard that used a buckling spring mechanism, deliberately designed to feel and sound like the premium IBM Selectric typewriters that American secretaries already knew and trusted. On August 12, 1981, at a press conference in New York, the company officially unveiled the IBM personal computer, known internally as the Model 5150. The base model launched with a price tag of $1,565. For that price, an American buyer received a system unit, a keyboard, and just 16 kilobytes of memory. Fast temporary storage the computer uses while programs are running. It did not even include a monitor or floppy disk drives, which were storage devices required to load software and save files. A fully equipped business system, complete with a monochrome display, dual disk drives, and a printer, could easily push the price past $3,000. Despite the high cost, the response from the American market was instantaneous and overwhelming. IBM had initially projected they would sell 250,000 units over 5 years. Available records indicate that retail demand was so ferocious, they were soon shipping as many as 40,000 units a month. For the first time, computers were not just sold by direct corporate sales forces. IBM struck distribution deals with retail chains like Computerland and the business centers of Sears Roebuck. A mid-level manager could now walk into a mall, purchase a machine on a corporate credit card, put it on their desk, and completely bypass the bureaucracy of the IT department. The American office was fundamentally transforming. Financial models that once took a team of accountants a week to calculate on paper could now be run by a single person in an afternoon. The IBM PC legitimized the entire microcomputer category overnight. It signaled to independent software developers that the corporate market was finally open and lucrative. The sheer gravity of the IBM logo had forced the chaotic, hobbyist-driven computer industry into a standardized, professional era. The box was ready, and with 3 letters stamped on its plastic case, the American office was finally willing to trust the personal computer. But that same open architecture would soon become the trap. In the fall of 1981, the American technology market experienced a profound retail shock. Historically, IBM sold its massive mainframe computers through an army of corporate salesmen in crisp blue suits, negotiating multi-year contracts directly with chief executives in boardroom meetings. But the IBM personal computer required an entirely different strategy. It was placed on the physical retail shelves of independent dealers like Computerland and the business machine centers of Sears, Roebuck, and Company. This was a distribution breakthrough. An American small business owner in Chicago could now walk into a mall, push a heavy cardboard box into the trunk of a car, and drive home with the computing power of a corporate giant. The physical machine was a heavy beige system that felt like it belonged in a serious accounting firm. but its true power lay in how it was built. IBM had designed the Model 5150 with expansion slots, physical connectors built directly into the computer's main internal circuit board that allowed users to plug in extra hardware. This meant an office could buy a base model and later slide in a video card, a dedicated chip that translated raw data into images on a monitor, or an extra memory board without having to purchase an entirely new computer. It turned a static, factory-sealed plastic box into a customizable workhorse for the corporate IT department. Data moved through the American office not by digital networks, but by human hands. The primary storage method of the era was the floppy disk, a flexible magnetic storage medium housed in a square plastic sleeve. A financial analyst in a Manhattan skyscraper would save a forecasting spreadsheet onto a 5¼ inch floppy, pull it from the drive, walk it down the hall, and hand it to a department manager. This physical disk became the new briefcase of the digital era. When a user turned on the machine, there were no colorful icons, no mouse pointers, and no friendly greetings. The system relied entirely on a command line interface, a stark, text-based software environment where a user had to type exact code instructions on the keyboard to make the computer run. The screen was a phosphor green void, displaying only the C prompt, a blinking line of text waiting for the Microsoft Disk Operating System, or MS-DOS, to be told what to do. The hardware was solidly engineered, but hardware alone could not win the American desk. A computer needed software that justified its steep price tag. In 1983, a Cambridge, Massachusetts-based startup released Lotus 123, a powerful software application that combined data calculation, database management, and chart generation. It was optimized specifically for the IBM PC's 16-bit processor, operating far faster than anything available on rival machines. Lotus 123 transformed the IBM PC from a glorified typewriter into a mandatory financial weapon. Wall Street investment banks, corporate accounting departments, and regional insurance offices bought the IBM machine specifically to run this one piece of software. Suddenly, a complex financial model that used to require a team of clerks and days of paper ledger math could be recalculated instantly with the press of a single heavy key. Soon, other vital software followed. Programs like WordPerfect, a dominant word processing application that allowed legal secretaries to format complex corporate documents, rapidly replaced the physical typewriter. This software boom created massive network effects. Because millions of American businesses were buying the IBM PC, software developers rushed to write programs exclusively for it. Because there were so many powerful business programs available, even more companies rushed to buy the hardware. It was a perfect ecosystem loop, locking the American market into the IBM standard. At the center of this explosion was a psychological moat that no competitor could easily cross. In the corporate world of the early 1980s, technology was an expensive, terrifying risk. If an IT director at a Midwestern manufacturing plant spent $50,000 on a fleet of Apple or Commodore machines, and the network failed to integrate with the company's mainframes, that director would likely lose their job for buying a toy. But if they bought IBM and the system crashed, the blame fell on the technology, not the buyer. This dynamic birthed the most powerful unwritten rule in American corporate history. Nobody ever got fired for buying IBM. The 3 letters stamped on the beige plastic casing represented a career insurance policy. It was a guarantee of service, stability, and absolute professional legitimacy. Yet beneath the massive sales figures, the retail expansions, and the absolute domination of the office desk, a structural flaw was waiting. Because IBM had built the Model 5150 using standard off-the-shelf parts to save time, they did not own the processor, which belonged to Intel. They did not own the operating system, which belonged to Microsoft. The only piece of technology inside the heavy beige box that IBM actually owned and copyrighted was the BIOS, Basic Input/Output System, the low-level firmware chip that woke up the hardware components, checked the memory, and handed control over to the operating system. The BIOS was the only legal wall protecting IBM's hardware monopoly. It was the digital translator that ensured software like Lotus 123 and MS-DOS ran perfectly on an IBM machine, but would instantly crash on any unauthorized copycat machine. IBM executives believed this single proprietary chip was enough to maintain total control of the empire. They assumed that as long as they held the BIOS copyright, they held the keys to the entire ecosystem. The IBM PC had won the American office, but the market was about to prove that trusting the brand was not the same as needing the brand. By the mid-1980s, the American corporate landscape had been physically and psychologically redesigned. The heavy mechanical IBM Selectric typewriters that had dominated office life for decades were pushed to the corners of the desk, replaced by the glowing green phosphor screens of the IBM personal computer. From the towering financial firms of Wall Street to regional insurance offices in the Midwest, the beige box became the absolute center of white-collar work. In 1983, IBM tightened its grip on the market by releasing the IBM Personal Computer XT. The XT looked nearly identical to the original Model 5150, but it included a crucial internal upgrade, a 10-megabyte hard drive, a storage device that keeps files, software, and operating systems even after power is off. Before the XT, American workers had to constantly swap physical floppy disks just to load a program and save a file. Now an entire accounting department could store its Lotus 123 spreadsheets, its client lists, and its financial forecasting models inside the machine itself. The physical ritual of computing changed. The loud grinding sound of the hard drive spinning up became the new heartbeat of the American office. The following year, IBM launched the PC/AT. It featured a faster Intel processor and a high-density floppy drive. The AT set the standard for computer architecture so firmly that its motherboard layout and physical expansion slot specifications would dictate how desktop computers were built for the next decade. IBM was no longer just selling a product. They were dictating the physical dimensions of the future. The sheer scale of IBM's victory was staggering. The PC division, operating out of Boca Raton, was generating billions of dollars in annual revenue. If the IBM PC division had been spun off into its own independent corporation at that time, it would have immediately ranked as the third largest computer company in the world, trailing only Digital Equipment Corporation and the rest of IBM itself. To service this massive demand, the retail infrastructure of America shifted. Independent retail chains like Computerland, MicroAge, and Businessland expanded rapidly across the country, building massive, carpeted showrooms. In these stores, corporate IT managers and small business owners could walk down aisles lined with heavy IBM boxes, purchasing fleets of machines, thick canvas-bound software manuals, and dot matrix printers. This hardware dominance triggered an unprecedented software gold rush. Because every serious American business was standardizing on IBM, developers poured all their resources into writing programs exclusively for the Microsoft operating system running on IBM Silicon. Programs like Ashton Tate's DBase, a powerful database management application, allowed companies to digitize thousands of paper employee records. WordPerfect dominated the legal and publishing industries, enabling law firms to format complex contracts on a screen before printing. In the American corporate office of the 1980s, the IBM PC was not just hardware. It was the physical proof that a company had modernized, the beige box that decided who had access to data, who typed the reports, and who belonged in the digital future. To the average American office worker, the computer was simply an IBM. It did not matter that the processor inside was manufactured by Intel in Santa Clara. or that the operating system booting up the machine was licensed from Microsoft in Bellevue. The trust, the corporate service contracts, and the cultural gravity belonged entirely to Big Blue. But IBM's staggering success had inadvertently created a new, highly lucrative concept in the American technology market: the industry standard. The ecosystem was growing so massive, and the software was becoming so valuable, that other hardware companies realized they did not need to invent a new computer. They just needed to build a machine that acted exactly like an IBM. The gravity of the IBM standard pulled the entire American tech economy into its orbit. By 1984, the ecosystem surrounding the beige box was generating billions of dollars independently of IBM itself. A new publication, PC Magazine, grew so thick with advertisements for third-party software, internal memory boards, and storage drives that individual issues rivaled the size of a big city telephone directory. Every page reinforced a single market reality. If a product did not plug into an IBM expansion slot or run on the IBM operating system, it simply did not exist to the corporate American buyer. Inside the Fortune 500, the IBM PC transitioned from a specialized accounting tool to a mandatory corporate fixture. Executive suites, which had previously shunned typewriters as clerical equipment, now prominently featured the heavy angled monitor of an IBM PC/AT. It was a physical status symbol, a heavy piece of industrial design signaling that the executive sitting behind it was connected to the modern, data-driven future. The cultural adoption reached beyond the corporate boardroom. In 1984, Harvard Business School made a groundbreaking decision. It required incoming students to purchase an IBM PC, or a strictly compatible machine. The computer was no longer just an office utility, it was the prerequisite for entering the American elite. In university, computer labs, and public libraries across the country, the soft hum of the IBM power supply and the glow of the green monochrome display became the environment in which a new generation of American managers learned to analyze the world. The network effects, the pattern where a platform becomes exponentially more valuable as more people, developers, and manufacturers use it, created an invisible fortress around Big Blue. Independent developers poured their lives into writing software for the IBM architecture because that was where the corporate budgets were spent. In turn, corporate IT departments refused to buy anything other than IBM because that was where the most powerful business software lived. The ecosystem expanded into dedicated hardware add-ons. Companies like Hercules built specialized graphics cards, internal circuit boards that gave the text-heavy IBM machines the ability to display high-resolution charts and visual data. These third-party upgrades made the original IBM hardware even more valuable, cementing the base system as the only logical purchase for a serious office. Available reports indicate that by the mid-1980s, IBM commanded more than half of the entire American personal computer market. The Boca Raton division, originally launched as a rogue, secretive experiment, was now shipping millions of units. The massive assembly lines could barely source enough Intel processors and third-party disk drives to meet the insatiable retail demand at chains like Sears and Computerland. To the executives in Armonk, New York, the strategy appeared flawless. They had successfully commoditized the chaotic microcomputer industry, tamed the hobbyists, and bent the personal computer to the will of the corporate office. They believed the heavy metal chassis, the legendary click of the buckling spring keyboard, and the proprietary BIOS chip were enough to maintain an eternal monopoly over the American desk. The American office had completely submitted to the IBM standard, but the empire was built on a dangerous illusion. The true power no longer lived in the beige plastic case or the corporate logo. It lived in the off-the-shelf silicon and the licensed software, and the market was already learning how to pick the lock. The first crack in the IBM empire did not come from a massive corporate rival. It came from a diner in Houston, Texas, in 1982, where three former Texas Instruments engineers sketched a design on a paper placemat. They had formed a startup called Compaq, and their goal was to build a portable computer. But their true breakthrough was not the physical hardware. It was a legal maneuver that broke IBM's monopoly. The only thing keeping competitors from perfectly cloning the IBM PC was the proprietary BIOS chip. If a rival copied that code directly, IBM's massive legal department would destroy them. So Compaq used a method called clean room reverse engineering, a process of analyzing a product to understand how it functions, then paying an entirely separate team of programmers who had never seen the original copyrighted code to write new software that did the exact same thing. When Compaq launched the Compaq Portable in late 1982, it was a heavy, suitcase-sized machine with a tiny green screen. But it did something miraculous. It ran Lotus 1-2-3 and MS-DOS perfectly. It was a 100% IBM-compatible machine, and it was entirely legal. Once the BIOS wall was legally breached, the floodgates opened. The American tech market shifted from trusting a single corporate brand to trusting a shared architecture. Because IBM had built its machine using standard off-the-shelf parts to rush it to market, any company could buy the exact same Intel processor. Any company could source the same floppy drives and power supplies. And crucially, because of IBM's original 1980 contract, any hardware manufacturer could license the MS-DOS operating system directly from Microsoft. A new and brutal category was born, the PC clone. In dorm rooms, garages, and startup offices, entrepreneurs began assembling beige boxes that looked and acted exactly like an IBM, but cost hundreds or thousands of dollars less. In a dorm room at the University of Texas at Austin, a student named Michael Dell began buying components, building computers, and selling them directly to consumers through mail order catalogs, completely bypassing the traditional mall electronics stores. This triggered the first major market force that would doom IBM, the collapse of hardware margins. The IBM PC was no longer an exclusive corporate luxury, it was rapidly becoming a commodity. The retail shelves at stores like Computerland and CompUSA, which once featured IBM as the undisputed king of the aisle, were suddenly crowded with cheaper, faster machines from AST Research, Tandy, and Gateway 2000. A corporate IT director in Chicago no longer had to justify spending $3,000 on an IBM machine when they could buy a functionally identical clone for half the price. The psychological safety of the unwritten rule, "Nobody ever got fired for buying IBM," began to lose its power against the raw mathematics of the American corporate budget. The clone machines booted up exactly the same way. The Lotus 1-2-3 spreadsheets calculated exactly the same numbers. The physical beige box was no longer special. It was just interchangeable infrastructure. As hardware became cheaper, the true center of gravity in the American technology ecosystem shifted from Armonk, New York, to the West Coast. IBM was still selling millions of boxes, but they were bearing all the overhead costs of manufacturing, global retail distribution, and massive corporate support networks. Meanwhile, Intel was selling the processor, and Microsoft was licensing the operating system for nearly every single clone on the market. Every time a cheaper competitor took a hardware sale away from Big Blue, Microsoft and Intel still made a profit. The ecosystem had been quietly hijacked from the inside. By 1987, IBM realized they were losing control of the very industry they had created. The open architecture was bleeding them dry. They decided the only way to save the empire was to close the ecosystem and build a wall around their corporate users. That year, IBM introduced a radically new line of computers called the Personal System/2, or PS/2. The PS2 line featured a proprietary internal communication system called micro-channel architecture, a patented hardware bus that allowed the computer's processor to talk to expansion cards much faster, but completely rejected the older, open-standard expansion cards the rest of the industry relied on. IBM aggressively patented this new system and demanded exorbitant royalties from any competitor who tried to clone it. Simultaneously, IBM partnered with Microsoft to develop a brand new, highly complex operating system called OS/2, intending it to eventually replace MS-DOS and lock corporate users safely back inside the IBM walled garden. The strategy was a massive gamble, forced the American office to abandon the open, cheap PC standard and return to a closed, premium, IBM-controlled world. But IBM misunderstood what the American technology market had become. The users were no longer loyal to the badge on the plastic case. They were loyal to the software ecosystem, and the ecosystem was already preparing to leave IBM behind. The American corporate market looked at the closed PS2 and OS/2 systems and collectively refused to follow IBM backward. IT departments had spent years enjoying the plunging prices of the clone market. They had no interest in paying a massive premium for a proprietary system just to restore IBM's profit margins. When Microsoft released Windows 3.0 in 1990, an operating system that provided a friendly graphical interface on top of the cheap MS-DOS foundation, the war was effectively over. Windows ran perfectly on the cheap clone machines. IBM's OS/2 was technologically sophisticated, but it lacked the one thing that mattered to the market: developer support. The ecosystem loop had completely inverted. Developers wrote software for Windows because that was what the clones ran, and American offices bought clones because they ran Windows. The architecture that IBM had created in a Boca Raton lab a decade earlier had mutated into the Wintel monopoly, a global market controlled by Windows software from Seattle and Intel processors from Santa Clara. IBM was no longer the ruler of the PC industry. They were just another tenant paying rent. However, before the final collapse of their consumer hardware dominance, IBM produced one last, brilliant physical triumph. In 1992, they introduced the ThinkPad line of laptop computers. Designed to resemble a traditional Japanese bento box, the stark, matte black machine was a masterpiece of industrial design. In the center of its keyboard sat the track point, a small red pressure-sensitive joystick built directly into the keys, allowing users to control the cursor without moving their hands to use a separate mouse. The ThinkPad became an instant cultural icon. In American airport terminals, first-class cabins, and executive boardrooms, the black plastic shell and the red dots signaled elite professional status. It was a heavy, durable tool that carried the old, undeniable gravity of the IBM brand. But the ThinkPad was a premium island in a sea of collapsing margins. The vast majority of the American computer market did not consist of traveling executives buying $3,000 laptops. It consisted of families, public schools, and small businesses buying basic desktop machines. And in that broader market, IBM was being slaughtered by supply chain economics. In Texas, Dell had perfected a direct sales model that eliminated the mall electronics store entirely. An American consumer or IT manager could call a toll-free number, order a custom-built PC, and have it shipped directly to their loading dock or front door. Dell held almost no physical inventory, while IBM was still weighed down by massive warehouses, retail partnerships, and heavy corporate overhead. By the late 1990s, the retail aisles at Circuit City, CompUSA, and Best Buy were flooded with budget machines from Gateway, Compaq, and E-machines. The personal computer, once a miraculous piece of corporate technology, had become a household appliance. The internal components were entirely commoditized. A processor was a processor. A hard drive was a hard drive. The logo on the outside of the plastic case no longer commanded a premium price because the software experience on the screen was exactly the same, regardless of who manufactured the box. By the early 2000s, IBM executives had to face a brutal mathematical reality. The company's PC division, despite the prestige of the ThinkPad and the historical weight of the brand, was bleeding money. The business of manufacturing physical computers had become a low-margin, high-volume grind. It offered no strategic advantage to a company that increasingly wanted to sell high-margin corporate servers, enterprise software, and IT consulting services. The American desk had been conquered, but the cost of holding the territory was too high. In December 2004, the creator of the standard finally surrendered. IBM announced it would sell its entire personal computing division to Lenovo for $1.75 billion. It was a shocking retreat for the American office, but it was the only logical conclusion to a process that began the moment they licensed off-the-shelf parts in 1980. The clones got cheaper, the software ignored the badge, the margin collapsed, the power moved to Seattle and Santa Clara. The creator of the PC was now just another hardware vendor. The architecture won. The empire lost. The IBM PC division was gone, but the machines they forced into existence had already rewritten the world, leaving behind a legacy that was much larger than a single corporate badge. The American office no longer features the three-letter IBM badge on its computing hardware. When Lenovo finalized the acquisition in 2005, the physical factories, the supply chains, and the engineering teams moved under new ownership. The legendary ThinkPad brand survived and thrived, retaining its stark black bento box aesthetic and its signature red track point. But within a few years, the IBM logo was scrubbed from the plastic casing entirely. The empire that had legitimized the personal computer in the United States had quietly erased itself from the American desk. Yet the ghost of the Boca Raton engineering team still dictates the modern world. The architecture that IBM created in a frantic one-year sprint in 1980 completely conquered the global technology market. Today, every single desktop and laptop computer on Earth that does not carry an Apple logo is structurally and fundamentally an evolution of the IBM PC. The concept of an IBM-compatible machine was so fiercely successful that the phrase itself eventually became obsolete. It was simply called a PC. The standard became the air the entire tech industry breathed. This total architectural victory is why a deeply passionate American preservation community refuses to let the original physical machines disappear. In the sterile Tempuewaki, off temperature-controlled display cases of the Computer History Museum in Mountain View, California, pristine examples of the original Model 5150 sit under archival lighting. But the true legacy of the system lives in the basements, garages, and workbench desks of vintage computer collectors, archivers, and restoration enthusiasts across the country. On specialized internet forums, vintage tech subreddits, and YouTube restoration channels, a dedicated subculture actively hunts for these heavy beige boxes. They scour estate sales, abandoned corporate warehouses, thrift stores, and e-waste recycling centers looking for intact hardware. When they find an original IBM machine, they carefully dismantle the heavy steel chassis. They use chemical retrobrighting processes to remove the yellowed aging from the plastic front panels, and they meticulously solder new capacitors onto 30-year-old motherboards to bring the dead systems back to life. They obsessively seek out the original Model M keyboards, drawn to the heavy mechanical, buckling spring switches that provide a tactile, aggressive click with every single keystroke. It is a stark, highly physical contrast to the flat, silent glass touchscreens of modern smartphones and the fragile membrane keyboards of contemporary ultra-thin laptops. This is not simply nostalgia. A teenager today restoring an old IBM PC/AT and loading MS-DOS from a physical 5¼ inch floppy disk is not just playing with obsolete plastic. They are interacting with the exact physical blueprint that built the modern digital economy. The old hardware is a mechanical argument about a time when American users physically owned their software in heavy cardboard boxes. When data was stored locally on loud, grinding magnetic disks rather than remote, invisible cloud servers, and when a computer was a distinct, standalone destination in a room rather than an always connected appliance in a pocket. The surprise footnote of the IBM PC story is the staggering scale of the wealth transfer it accidentally initiated. When IBM executives allowed a tiny, 32-person startup in Washington state to retain the licensing rights to the operating system, they believed they were making a pragmatic, low-risk decision. They assumed hardware manufacturing was the only permanent moat in the technology industry. Because of that single contract clause, Microsoft leveraged the IBM standard to become one of the most valuable corporations in human history, building a trillion-dollar software empire entirely on the foundation of IBM's beige box. Intel, providing the processors, reaped identical rewards. The Wintel duopoly completely extracted the massive value that IBM had originally created. The fall of the IBM PC empire was not caused by a failure of engineering, a lack of corporate funding, or a sudden loss of consumer trust. It was destroyed by its own flawless execution. IBM designed an open architecture so perfect and so universally adaptable that the market no longer needed the company that invented it. They taught the American office how to embrace the digital future. But in their rush to dominate the desk, they forgot to maintain control of the ecosystem that powered it. IBM believed they were selling a premium box. In reality, they had paved a digital highway for the rest of the world, and they had forgotten to build a toll booth. Once the road was open, the developers, the clone manufacturers, and the users simply drove past them, leaving the corporate giant in the rearview mirror as hardware margins collapsed. Somewhere in a quiet American basement, a heavy beige Model 5150 sits on a wooden desk, its mechanical power switch flipped upward with a heavy, satisfying clack. The internal fan whirs to life, the floppy drive grinds loudly as it seeks data, and the heavy glass of the monochrome CRT monitor warms up, displaying a solitary, blinking green line of text, waiting for a command from an empire that has long since surrendered the desk. See you in the next one.